Hello, hi everyone. Welcome back to the channel. Here in this particular video, we are going to discuss about OWASP Docker Top 1 D01, which is Secure User Mapping. So as we discussed in the last video, we are going to start a series regarding OWASP Docker Top 10. Okay. So as a part of that, I was covering like what exactly means the like secure user mapping and why the secure user mapping is critical and what are the attack vectors for like secure user mapping like exploitation and what are the some examples of our secure as well as insecure implementation and how to implement a secure user mapping in Dockerfile as well as while running a container and some advanced topics regarding user namespace mapping, how we need to map securely and how I mean we need to verify a container user settings and some real world like impacts of poor user mapping and its exploitability level and what damage it caused, and finally the summary like how the what the things we have learned in this particular video. Okay, so without further ado, let's enter into the video. And one more thing, I was not covering any practical demonstration in this particular video. Why? Because for explanation it was taking too much time, sorry. And I will try to keep the sessions after completing this series of videos. By that you will also feel kind of a clarity on this. Okay, and without further ado, let's enter into a D01, which is OWASP Docker Top 1 Secure User Mapping. Okay, so let's see what exactly the secure user mapping is. Okay, if you see, the secure user mapping is nothing but running a containers with a specific user, the two non-privileged user account. Okay, so the user should not have a root permissions, and mapping a container users to a host system users safely and avoiding root privileges inside the containers whenever it is possible. Okay, we need to make sure whenever there is no need of root privileges in the particular container, we need to avoid the permissions. Okay, and essential Docker security practices for production environments. Okay, so this is one of the key important feature where like especially while following some security frameworks at the time, it is important to implement. It is like mandatory. Okay, and implements a principle of least privileges in containerized applications. Okay, so principle of least privileges in the sense who can access what. So there is a limited kind of permissions will be given to that particular user to perform the particular activities only. Okay, so that is what exactly the secure user mapping was. Okay, and now let us see like why is secure user mapping is critical. Okay, so these are the some pointers which we get to know. If we compromise on this user mapping, then obviously this will affect. These are the things. Okay, so root containers is obviously is equals to full system access if it was breached. Okay, so that is the one of the key critical component, and container escape can compromise the entire host system. So let's say if attackers tries to like come out from the container, then obviously they can enter into a system and they can compromise the host system. Okay, and the principle of least privileges obviously reduces the attack surface significantly. Okay, as we discussed in the earlier slide where whatever the access is required to whom, that particular access is provided to a particular person only. Okay, and never run your containers as root in production. Okay, so this is also one of the key point we need to consider. And compliance requirements, especially like SOX, PCI DSS, HIPAA, these are the secure user mapping is mandatory for these compliance requirements. Okay, so that is why the secure user mapping is very much critical. Okay, and one more thing, I don't have a mouse as of now. I just handling with the mouse pad. If something goes wrong, don't feel bad. Okay, I try to keep the things as like favorable as possible, and if just something goes a little wrong, just excuse. Okay, and moving to the next slide, which is regarding Docker attack vectors and how the attackers can exploit the poor user mapping. First of all, let's see what is attack vectors. Okay, so attack vector is basically what by using what the attacker is exploiting. Okay, that is basically attack vector. Okay, there is a lot of terminologies if you see in cybersecurity, especially this WAPs also. Attack vector, attack surface, vulnerability, CVE score, and CVSS, all of those things. Okay, so if you are already into this particular space, then it will be kind of noted for you, and daily you are hearing those words. But if you are someone new, then obviously you will feel a little different words. Okay, but don't worry, you will get habituated for it. Okay, and coming to the attack vector, first one, which is the container breakout. Container breakout is basically a root containers allows some kernel exploits to escape a sandbox and access to the host. Okay, so breaking out from the existing container, that is basically a container breakout. Okay, and file system access. So the root access enables a reading, writing, and the sensitive information or files in the host files directory. So this is also one of the attack vector. And privilege escalation, obviously by using some Linux capabilities or some binaries like SUID, okay, root user ID binaries. Obviously, the attackers can use those capabilities and gain the like root privileges. And process hijacking. This is basically root containers can manipulate like host processes and system services. So this is also one of the attack vectors. There are multiple attack vectors also, but these are the like major attack vectors if you see regarding a secure user mapping. Okay, and moving to the next slide, where we are going to talk about some example for secure as well as insecure implementation. If you see insecure, which is bad, I mean bad practice, we can say. Okay, so here let's go one by one comment. Docker run nginx. Basically, this particular command runs a container as a root by default. No user is specified in this particular case. Okay, and here if you see from Docker, I mean from Ubuntu, this basically means base image is used here, but no user is configured. Okay, and uh, if you see here, run apt get update, which basically updates the packages and still running as a route. There is no specific user is configured. And this particular command, no user directive in Dockerfile. Okay, so I mean, this is not a command. I mean, till this was, I mean, whenever we are writing a Dockerfile from run working directly like that. So if you see here, there is no user was set up here, right? So here we are just saying there is no user directive in this particular Docker file. Okay, so obviously if there is no user directive, then it will use a root which is user ID will be 0. Okay, other than root, I mean UID 0, that will be a non-root user. If we not specifying any user in the Docker file, then obviously it will consider UID 0. Okay, that means it has a full system access. If breached, high security risk will be found. Okay, and coming to the secure way, which is a good practice, we can say this particular command basically runs a container as non-root user with UID 1001. Okay, so this was the like user ID. And I mean, as I said, if it is 0, then it is a root, and if it is a non-zero, then it will be a non-root user. Okay, and if you see here in this particular Docker file, this was the best practice Docker file where we are using same base image, but now we added here user here in that particular command. If you see, there is a command run. Yeah, there is a particular command run user add -m app user. This was the username. This was the like argument we need to pass for adding a user. Okay, and then we are switching to this particular user, and whatever the commands we run of I mean below this particular user app user, under this will run in this particular with this particular user only. Okay, and there is no like a root access for this particular user. Okay, so uh, and here, if you see here, user 999, this is explicitly sets the user ID and group ID. This is user ID, UID, and this is GID, which is a group ID, to a non-root values. Okay, so if you see here, it will limit the container privileges safer for especially production. Okay, so it is UID greater than 0. If you see here, UID is equals to 0. That is the difference here in this insecure and secure way. Okay, and moving to the next slide, where we are going to talk about how to implement secure user mapping. Okay, so there are two methods. One is Dockerfile method and one is runtime method. Okay, so this Dockerfile method basically sets up a non-root user inside the container during the image build. Okay, and here in the runtime method, it will set the user at the time of running the container. Okay, those are the like slight differences, which is at the time of running a container and before, I mean at the time of building a image itself. Okay, and if you see here, this was the like a Docker file which we have just seen in the earlier slide, where we are using. I mean, I will go one by one argument in this particular Docker file. Like from Alpine, basically it uses a lightweight base image, and then we are using run add user -d-s bin sh app user. Okay, so this particular command creates a user named app user with no password and shell access. That is the like significance of these arguments. And the third command was user app user. Basically, we are switching to the non-root user for all the following commands, whatever process below this particular command. Okay, so here the next command was setting up your working directory to home and app user. It will basically sets the working directory for the app inside the container. Okay, not outside, it is inside a container. So basically, this will ensure the container runs as a non-root user by default. And coming to the like runtime method, sorry, yeah, coming to the runtime method, where we use I mean, as I said, this sets the user at the time of running the container, and this was the command docker run -user and UID and gid group id and -v, which is I will tell all the arguments. -v host data, and then data my app and latest. Okay, so let's like divide all these particular things. What exactly this particular command does? Okay, so docker run, it is basically running a docker new container. Okay, and then hyphen user and uid gid. Okay, so it will runs the containers as a uid is 1001, which is a non-zero, which is a non-root user, and then gid also a group user id also, which is non-zero, which is 1001, and then this particular argument -v host data and semicolon data my app. Basically this mounts a volume from the host to the container. Okay, so for mounting a volumes, if you see our last lectures, old videos where I have explained a concept regarding the docker volumes and mounts. Okay, so that is basically just mounting a volume from here host to this particular docker container. Okay, and this particular argument my app latest, this specifies the image to run. Okay, whatever the target image we need to run, this is the image name and then argument associated tag, we can say. Okay, this particular method is useful when you want to override the default user at runtime level. Okay, and the best practices was always we need to specify a non-root user, which is uid greater than 0, avoid uid 0, which is a root user, to reduce the risk, and run with the least privilege principle. Basically that will use only the access they need, nothing more than that. Okay, so that is the significance of these best practices. And moving to the next slide, where we are going to talk about advanced user namespaces mapping. Okay, what exactly this means? So here maps a container root to unprivileged host user automatically. Even if a container runs as a root, that is uid 0, Docker remaps that particular user to a non-root user on the host machine. Okay, so this happens behind the scenes. That is the significance of namespacing here. Okay, so if you see the next point, which is provides a additional security layer to at Docker daemon level. Okay, basically this feature is enabled globally at the Docker engine level, not per container. Okay, so it adds a strong layer of protection across the containers, and container UID is not equals to host UID 0 mapped to a high UID. Basically, this specifies inside a container UID 0 is still exists. Okay, but on the host it's mapped to a high user ID, some 10000 like that, which has no root privileges. That is the significance of these pointers. Okay, and even if container runs as root, host seems to be non-root. Basically, this means legacy applications can still run as a root inside a container, but the host treats them as a harmless. Okay, why? Because that was the unprivileged user. Okay, and this is the command how it let me yeah, this is the command how uh, how the daemon configured the file. Okay, so this was the command. Okay, so basically this was the docker daemon file, which is a .json file, and once we set up this, then we restart the Docker service by this command sudo systemctl restart Docker. This will basically activates user namespace remapping for all containers going forward. Okay, so that is the significance of this particular command and using it namespaces. And moving to the next slide, which is tools to verify a container user settings. So this is also one of the key aspect. Why? Because Docker inspect will be happened here in this particular stage, where this was the one of the a tool, we can say, Docker inspect to this was the one of the argument, we can say. Okay, so it was a default. I think so this was the built-in feature to view the containers configuration and some which user is running that particular container. Okay, by using Docker inspect we can check the user configuration details. So this was the to verify the container user, this was the command docker inspect container name and then pipe grep -i and then user, which is case insensitive, and the with the word user, if it founds, then whoever associated user is there, then that will shown. Okay, with the help of docker inspect command. And process mounting, basically you can check which user is inactive inside a container by running these particular commands. Okay, to view the running users, we can say. Okay, docker exec container name and then who am I. Okay, so basically this particular command displays the current username, and docker exec container name and id. ID, I mean, just a word we need to write. I mean, ID. Basically, it will shows the UID, that is user ID, and GID, that is group ID, and group memberships also. Okay. And coming to the security scanners, where it will automated checks will be happened. Tools like a Docker branch for security, or I mean, basically, this will scans automatically for containers for some misconfigurations, or where the containers including insecure user settings. So this was the use case of this particular command. Okay, it will basically list the process with the users. So to see all running processes and which users are executing them. Okay, those processes. So this particular command, Docker exec container name ps AUX. Okay, basically this particular command helps to verify if any process is running as root or another user. So that is the significance of all these particular commands. Okay, and these were all the Docker inbuilt features only. Okay, you don't need to explicitly download other packages. Okay, and moving to the next slide, where we are going to deal about a real world impact of poor user mapping. Okay, so we till now we discussed many more information about D01, which is insecure user mapping. So with poor user mapping, what is the real world faces like earlier, or else what might be the impact of that? Okay, so this was the one of the example. If you see here, 2019 RunC vulnerability, which is a CVE score, I mean CVE ID, this is the ID, and this exploited your root containers. So this was a major security flaw in Docker's container runtime, which is RunC, okay, Docker container runtime, that is a RunC. Okay, if a container was running as root, an attacker could override the RunC binary and gain the control of the host system just by running a malicious container. That is the concept of RunC here. Okay, and coming to the second point, container breakout is equals to full host compromise in seconds. So let's say once inside, attackers could escape the container's sandbox and take over the host missions. So this kind of a breakout is very fast and uh, devastating when especially the containers run as a root. And coming to the third point, which is privilege escalation attacks succeed with 90% plus success rate. So when your containers run as root, attackers can obviously easily exploit the known vulnerabilities to gain a full system access. Um this basically studies show, I mean, some of these studies shows these attacks are highly successful in real world scenarios. Okay, so that is the significance of 90% plus success rate. So because of privileged escalations, because of I mean, user mapping was not correctly done. And the next point was the file system access beyond intended application boundaries. So basically, this happens poor user mapping. Obviously, that allows a container to access some sensitive files on the host machine, like configuration files, SSH keys, or some logs, which they should never see, or else some sensitive data is available. Okay. And the next point was regulatory compliance violations results in $1 million fines, especially the standards like HIPAA, HIPAA, and CPIDSS, and SOX. This requires a strict access controls. Running a containers as a root can obviously lead to non-compliance, and that will trigger your legal penalties also, and some massive fines also. Okay, and coming to the last point, which is the data breaches, system takeover, and reputation damage. Obviously, like there might be a unlimited cost. Okay, like unexpected cost, we can say. Okay, and data will be stolen, and hijacks may also happen, and customers trust obviously we will lose. So these are the some real world impacts of a poor user mapping. Because of poor user mapping, these other things may impact. Okay, and moving to the another slide, which is I think the last slide, where we are going to discuss some summary whatever till now we have covered, and what is the immediate action plan. Okay, so here we are talking about the core principle. Basically, the core principle was never run a container as a root. Always follow the least privilege principle, which means basically giving a container only the access they absolutely needed, nothing more than this. This is the foundation of your container security wherever you are implementing and whatever you are implementing. And implementation. So you can enforce non-root user in either two ways. Okay, so one was Dockerfile method, and the another one was at the runtime, which is using --- user flag. Okay, so whenever we are using a Dockerfile method, we need to use a user directive to specify a non-root user during the image build stage. And whenever we are using a runtime method, we need to use a --- user flag when running the container to override a default user. That is the like two implementation strategies. So both these methods ensures user containers doesn't run with like dangerous root privileges. And coming to the advanced security, where it will enables user namespace remapping at the Docker daemon level. We have seen the command and some respective points also in the earlier slide. Okay, so basically, this will enables a user namespace remapping at the Docker daemon level, and this maps a container like a root user, which is a UID 0, to a harmless and providing a high UID, which is greater than 0 on the host machine, and adding some powerful layers of the protection across the all containers. And coming to the verification, where we always need to check which user uh, containers are running, and by using some inspect command, uh, we can obviously set up a kind of continuous monitoring to catch the misconfigurations early at the runtime. And this was the just a quick check where we will run this particular script to list all the running containers, and this particular the script shows the like all the running containers and their configured users, which user is associated to which container and what they are running. So this particular thing will basically helps you to quickly spot any containers still running as a root, and you can take some necessary actions accordingly. And finally, secure user mapping is first line of defense. That is why in OWASP also it was in top list. And whenever you are implementing Docker security, so start with secure user mapping. Okay, so obviously whenever we are following a best practices, we should remind this was the like significance of following the best practices, whatever the things we are covered till now. Yeah, that's it in this particular video, and stay tuned for more videos. Thank you.